Morning children, back to school again as per my promise for CBSE sample paper 2023-24. Let's have the discussions on question number 17, right? The question number 17 is related to your half wave versus full wave rectifiers and the identifications, right? As I told you all, we are not preparing here the questions and the answers. We are trying to figure out what are the types of things which comes in the board examination as a sample, right? So question number 17 is on half wave versus full wave rectifier. Now basically, before discussing the half wave and full wave rectifiers, let me tell you about slightly the importance of PN junctions in forward bias and in reverse bias. PN junction diodes, if you have studied already, PN junction diodes in forward bias is a conducting situation and in reverse bias is a opposing situation. Am I right? The biasing is very much important for the PN junctions. Now to create one half wave rectifier, look at what are the things you require for. One diode, a PN junction diode, and one input voltage across the diode. That is, from the primary sources you will be getting the alternating current or the AC voltage or current, and you will be feeding it to the secondaries, and this will be passing through the PN junction diode, right? And the working of this is based on only one diode, one output load resistor, one secondary coil and one primary coil fed with the alternating voltage or the current. Am I right? So let us see quickly what happens when alternating current or the voltage or the signal is passing through the PN junction diode. When the positive, let us say P1 and P2 are two terminals marked here. When the P2 is positive and P1 is negative, P2 is positive and P1 is negative. Look at, due to the induction, what will happen? S1 will be positive and S2 will be negative. Now when S1 will be fed to the P of the diode, S1, the positive waveform, will be fed to the P of the diode, then it will be a forwarding situation. It will be forwarding situation or forward bias, right? So what will happen? That time the diode will be conducting. And you will be getting one output across the RL. The load output will be getting across the RL. And the reverse situation, when P1 will be positive and P2 will be negative. When P1 will be positive and P2 will be negative. When P1 is positive, by virtue of induction, what will happen here is this will be negative and this side will be positive. So obviously what will happen? P will be biased with negative terminal. So P will be getting one signal of negative. So that time the diode is not going to conduct. Clear? So this PN junction diode, when fed with one AC signal, when the positive terminal is fed to P, you will be getting the conduction and you will be getting the output through RL. And if opposite of this happens, reverse of this happens, then you will not be getting the output across the RL. This is what is half wave rectifier. Please do understand clearly. PN junction diode, only one diode is used here, and you will be getting the output for half of the cycle only. So voltage at A, if you look at voltage at A, you will be getting for the positive one, when voltage positive at A, you will be getting the RL voltage developing that time. But when voltage at A will be negative, the signal will be negative, that time the output voltage will be missing. Again, when the voltage at A will be on the positive side, the output you will be getting, and when it is on the negative side, you will not be getting the output. That is why IDC, the output current, DC current across the output or the load resistor will be equal to I0 upon pi. Calculations you can do or you can check out from your book. And the pulse frequency here will be equal to the frequency of the AC. Frequency of the AC. Okay. This is what is called half wave rectifier. And quickly let us see what we do technically for the full wave rectifier. Right. So as you see, what is the demerit here? When the P is fed with the negative signal, that time unfortunately there is no load developed. There is no output developed that time. So you are missing a part. Almost mathematically I would say that half of the cycle is conducting here and negative half of the cycle is not conducting here. So this is the demerit of your half wave rectifiers using PN junction diode. Right? Now look at here. For full wave rectifiers, what we do technically is we use two diodes D1 and D2, and modifications quickly you check out what we have done here. The primary source is here, the secondaries will be getting across this, and diode D1 and D2 are connected in such a way that from the common of the N, if this is your P and this is your N, this is your P and this is your N. So from the common of the ends, you are taking one connection and connecting to the load resistor R, and the secondary is center tapped here, and one terminal from secondary center tapped is connected across RL. So see technically what happens here. When diode D1 and D2 are connected in such a fashion, then you will be getting, let us say P1 and P2 you look at, for the positive half, when P1 is negative, P2 is positive, this side is negative, this side is positive, and this terminal will be in between. The center tap will be 0 or in between the positive and negative. So what happens here? For the positive half cycle of the input, positive is fed to P and negative is fed to 0. That means diode D1 will be conducting for this. And when the negative cycle happens here, diode D1 is unable to conduct because reverse bias. But that time, when diode D2's condition you look at, that time diode D2, if wave at B, you can look at, if wave at B you will be getting, that time it will be positive. The diode D2 will be connected to positive and N will be connected to 0. So quickly what you see, wave at A is positive, that time wave at B is negative. When wave at A is negative, that time wave at B is positive. So obviously what you are getting is diode D1 and D2 both will be capable of one after the other. When diode D1 is conducting, that time diode D2 is getting a reverse bias, and when diode D1 is not conducting, that time diode D2 is getting a forward bias. And you will be getting, both the diodes will be helping you out, and you will be getting the output always available, whether the signal is for positive or negative AC. So what we get exactly here is, by technically modifying the circuit, taking the help of two diodes D1 and D2, we will be getting clearly the output at RL. The wave at RL will be always developed. That means you will be getting the alternating signals converted to the direct signals, or for positive half cycles you will be getting it. For positive side you will be getting it always. That means the IDC will be approximately equal to 2 times of I0 upon pi. 2 times of I0 upon pi, whereas half wave rectifiers you got I0 upon pi. So this is the basic difference. And what you will be seeing here is the frequency also. The pulse frequency will be twice that of AC, because for every frequency of AC, whether it is positive or negative, you are getting one output. So pulse frequency will be double of that of the input AC. Clear? So thank you so much for question number 17's discussion. Patiently listening to it, and I hope you are preparing well for the board examination. So go for the half wave and full wave rectifiers once again, though you have studied in classroom scenario, fine, but recapitulate, revise, and you get the basic difference between the p-n junction diodes used in half wave rectifier and used in full wave rectifiers. Okay. One of the next discussions, when I get my time, I will be appraising you, I will be telling you on how the p-n junction diodes are forward biased, how the p-n junction diodes are reverse biased, and what are the uses of p-n junction diodes in the typical semiconductor instruments or devices. Okay, thank you. Signing off.